Over the last 20 or 30 years, we've learned a lot about the role of soil life in soil fertility, particularly the role that microbial life plays in helping to make nutrients that are in that mineral part of the soil available to plants that can take them up as nutrients. The arguments about sort of what frames soil fertility go way back through history. Obviously, people have long thought about the mystery of fertility. Early on in our history, we deified fertility, sort of ascribed it to the workings of the gods. Today, we've come almost to the opposite end of the spectrum in thinking of microbial life as the great engines driving fertility in the soil, helping to facilitate the breakdown of organic matter, dead things in the soil that contain the nutrients that used to be alive, that could be recycled into new life if only they could be unlocked from that organic matter, and also from the mineral matter. Now, we can't eat rocks, right? But if you look at what makes up our bodies, other than the carbon, the nitrogen, and the water, all the other sort of the minor elements that are so critical to our health, ultimately all are derived from rocks. Plants can't eat rocks either. What does? Microbes. The microbes are incredibly important. That soil life, the invisible part, the hidden half of nature we can't see with our own senses, is the part of soil life that really helps bring out the fertility in natural soils and facilitates that with plants. And one of the truly amazing things that's been speculated about for over a century, but has really been documented in the last couple decades, is the degree to which microbial life forms partnerships with plants, true symbioses between the microbial life living in the root zone or the rhizosphere of the soil, sort of close to plant roots, how those microbes are exchanging nutrients with plants for the benefit of both. Plants, of course, have a monopoly on photosynthesis. They can take sunlight and turn it into complex organic molecules. Turns out that they'll pump a surprising amount of that stuff out of their roots into the soil. I was trained to think of roots as straws, things that draw material out of the soil for the benefit of plant nutrition. But it turns out they're two-way streets. They're putting material out into the soil. Why would they do that? Why would they waste all that energy? Well, they're not wasting it. It's to feed the microbes that are actually providing the plants with things in return. Things like phosphorus, zinc, manganese, the micronutrients that help facilitate plant health, but they're also producing things like plant growth promoting hormones. Why would microbes do that? Well, in exchange for sugars and other exudates that plants put out through their roots. And that partnership, the partnership between mycorrhizal fungi and bacteria and plants, goes back to the very first plants that colonized the continents. The first fossils that we know of from some 450 million years ago of plants on land actually have mycorrhizal fungi entangled with the roots. The microbes colonized the continents first and helped the plants come ashore.